Uh, Now I've seen a handful of examples already where I've just come in with some rules and some formulae and I've stated that NPR is equal to n factorial by n minus r factorial. I've stated that NCR is equal to n factorial by n minus r factorial. I have stated that when repetition is not allowed, you have to do 5 into 4 to 3. But when repetition is allowed, I have to do 5 into 5 into 5. Now, how do I know this? Why does it work? Why should you believe me? Important question. Now, all of this comes from the first principle in this chapter, which is something called the fundamental theorem of counting. Before I state it, just a small example. Let's say I have 3 towns A, B and C. And there are 3 roads from A to B and there are 4 roads from B to C. If you want, you can just call them P, Q, R, S, T, U, V. The question is, how many ways can I go from A to C through B? And the answer to this would be, there are 3 roads from A to B and there are 4 roads from B to C. 3 into 4 is equal to 12 different routes can be figured out. Right? If you want to see them, it would be PS, PT, PU, PV. That's 4. There's QS, QT, QU, QV. That's another 4. RS, RT, RU, RV. That's another 4. That's a total of 12 different routes. The basic idea here is, I have a 2-step process. My process is going from A to C and it's a 2-step process. Step 1 is going from A to B and step 2 is going from B to C. And more importantly, step 1 and step 2 are independent of each other. Right? I can do whatever I want in step 2 irrespective of what I've done in step 1. Right? So when you have a 2-step process and step 1 can be done in 3 ways and step 2 can be done in 4 ways, and more importantly, steps 1 and 2 are independent, then the process itself can be done in 3 into 4, 12 ways. This is basically what fundamental theorem of counting is. Right? If you have a multi-step process, you break them down into independent steps and you see how many ways of doing each step. Then you take the product of all of this. Right? That is basically what fundamental theorem of counting is, and the reason it's important is because this is where NCR and NPR, all these things are derived from FTC. This thing is called FTC, and FTC is basically what you use to derive NCR and NPR. Right? So it's the first principle of this chapter. It's actually easier to explain the derivation of NPR. So if you look at the Scrabble example, I had 5 different tiles which cannot be used, each tile cannot be used more than once, and I had to make 3-letter words, right? Now making a 3-letter word is a 3-step process. This is my 3-letter word. Once I fill the dashes with letters, I'll have a 3-letter word. It is a 3-step process. Step 1, determine which letter will go into the first dash. Step 2, which letter in the second dash. Step 3, which letter in the third dash. Now this can be, you can apply FTC here and see what happens. Now I have 5 tiles to choose from. So the first dash can be filled in 5 ways. I don't know which letter is going there. It could be A or B or C or D or E. It doesn't matter which one. Right? Whichever letter I put here, that letter is now out of the picture. I have only 4 more letters to choose from. So when I do step 2, which is fill the second dash, I have only 4 letters to choose from. So into 4. And then 2 letters are now gone. I can choose any one of the remaining 3 for the last dash. Then it becomes 5 into 4 into 3. So when you apply FTC directly, you will get the NPR formula. The derivation is very simple. This was the Scrabble example, of the one where repetition is not allowed. What about the faulty keyboard where the repetition was allowed? Again, I have to make 3-letter word. That's a 3-step process. Fill dash 1, then fill dash 2, and then fill dash 3. Now because I can strike a functional key any number of times, and the letters were available to me were A, B, C, D. These were the 5 functional letters. The first dash is the first keystroke. I can either strike A or B or C or D or E. There are 5 ways of doing this. Now, when you come to the second dash, you still have access to the same 5 keys and you can hit any one of them, which is why you get the same number. So when repetition is allowed, the first dash can be either A or B or C or D or E. 5 ways. Second dash also can be any of the 5. Third dash also can be any of the 5. This is what happens when repetition is allowed. You get the same number. From a formula point of view, this would be n raised to r. This would be npr. That is the difference. Deriving NCR is a little more complex. You're actually dividing a permutation by another permutation to get this. And we'll see that next.